explore data science analysis as part of our machine learning sprints. The presentation can be broken down into 12 sections as showed in this slide. And without further ado, I'll give you a little bit of background and context to the project. Climate change is defined as a global rise in temperature from the mid-20th century to present. And some of the major contributors to the climate change are greenhouse gas emission, industrial activity, combustion of fuel, deforestation, and many others. There is an illustration of some of the areas where the carbon footprint can be reduced. According to the BBC, individual and company can collectively reduce the carbon footprint by following some of these steps. Nowadays, most companies are trying to reduce the carbon footprint by offering products and services that are environmentally friendly and sustainable. The problem that we had at hand was to create a machine learning model able to classify whether or not a person believes in climate change based on Twitter data. Companies would like to determine how people perceive climate change so that they can get insight on people's view and perception about climate change, improve market research for companies that provide products and services that are eco-friendly, and promote effort of reducing carbon footprints. The objective of these studies was to provide an accurate solution, robust enough so that company can assess a broad base of customer sentiment to obtain F1 score higher than 0.7 and to deploy our machine learning on an open source app framework called Streamlit. The tools used for this study were Kaggle, Comet, and Streamlit. The process followed for our machine learning included exploratory data analysis, feature engineering, data preprocessing, model training, and deployment. Here is a framework illustrating our modeling pipeline. The data at hand was a collection of tweets related to climate change that were collected between April 2015 and February 2018. There was a total of 43,943 tweets collected. They were divided into 4 classes, as showed on the slide. Those 4 classes included the first one, class 2, which was a news, a collection of tweets that represented news. Class 1 was the collection of tweets that were in support of the belief that climate change was man-made. Class 0 was a collection of tweets that was neutral, which means that there was neither a belief or neither a disagreement, a disbelief that climate change is man-made. And class -1, which was a collection of the tweets that does not believe in man-made climate change. Our data consisted of 3 variables, i.e. columns, which were the sentiment of the tweets, the body of the tweet, and the tweet's unique ID. Here is a sample of our data frame and how it looks with our variables. Data processing was our following steps in the following step in the study. It included cleaning some of the text data, where at the beginning it was about removing the duplicate value and null value, and also some basic text processing such as converting our text into lowercase, removing punctuation, replacing white space and removing stop words. The different classification techniques that were used included a support vector machine, naive Bayes classifier, k-nearest neighbors, random forest, and a tree-based classifier. This is the counts of our different classes, where we can clearly see that the pro-climate change class was the majority of our tweets. They actually accounted for 54% of the data, and the remaining classes accounted for 46% of the data. This imbalance in the data is an indication of a bias that can negatively affect our classification model. And in order to go around this issue, it was necessary to resample the data before training our model on it. The model was deployed on Streamlit. And just before that, on this slide, you can see the different models, the different classification model, and the accuracy score. Here is the configuration and interface of a Streamlit where the model was deployed, which allow for our user to enter a text, to choose which model they would like to use for classifying the text, as well as additional functionalities such as FQA, as well as exploratory data analysis. Visualization that we used included like a graph, like a histogram representing the different classes, as well as after pre-processing our data to resample them so that you can have a balanced model. Word cloud. The word cloud included like the word cloud included the words that came out the most within our tweets, and a bar graph of the accuracy for each model that was trained on the data. This is a confusion matrix for the models that performed the best. There were 4 models that really performed well, which are the linear support vector, the SGD classifier, and the support vector classifier. Here are the classification reports showing the accuracy score for each of these models. These are the ones that had a F1 score greater than 0.7. In conclusion, we drew some insights that showed that the majority of people agree that climate change is real. And this means that the company effort into providing products and services that are environmentally friendly are likely to receive support from the public. Another insight is that our linear support vector model was the model that performed the best. We are able to obtain a F1 score greater than 0.7. And the result shows that more people believe in climate change, that climate change is a global threat. Thank you for following this presentation, and please feel free to drop your question on the comment section.